Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling to the very edge of the universe. From the first whisper of creation to the farthest places light can reach, we'll explore 100 sleepy facts about cosmic horizons, expanding space, and the dreamlike mysteries that lie beyond our sight. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The quiet beginning. Long before galaxies blossomed and stars took their first warm breaths, the universe was a tranquil sea of glowing energy. There was no shape, no space to drift through, only a soft, dense warmth waiting to unfold. As this ancient glow expanded, it began to thin, like a mist gently lifting from a still lake at dawn. From that thinning light, the very canvas of space stretched outward, carrying the seeds of everything that would one day shine. Imagine it as the universe's first exhale, slow and patient, filling a darkness that had never existed before. And from this gentle breath, the story of distance quietly began, inviting us to follow it farther. Fact 2. Light's first footsteps. The earliest photons, the first particles of light, set off on their journeys when the universe was still young and hazy. Before this moment, light couldn't travel freely. It was scattered endlessly by the thick soup of charged particles. But as the cosmos cooled, it became clear enough for light to slip through, drifting outward in long, uninterrupted paths. These ancient photons are still moving today, continuing their patient voyage across expanding space. They hum softly through the universe as relics from a time when everything was just beginning to take shape. Their quiet persistence reminds us that even the faintest glow can travel a very long way. Fact 3. The soft expansion. The expansion of the universe is not a sudden or violent event. It is gentle, steady, and wonderfully calm. Space stretches like a slow tide, creating more room between galaxies without pushing on anything at all. This expansion doesn't require a center. It unfolds everywhere at once, like a fabric being woven in every direction. Over billions of years, this subtle stretching has carried distant light farther and farther away, softening it into cooler shades of red. If you imagine the universe as a vast, breathing field, each moment widens its horizon a little more. And just beyond that widening edge, new mysteries wait quietly in the dark. Fact 4. A sea of cosmic fog. In the early universe, long before its stars had kindled their first blue-white flames, everything was wrapped in a thick cosmic fog. This wasn't a fog made of droplets, but of particles so energetic they kept light from traveling freely. Photons bounced and scattered, unable to journey more than a breath before being turned aside. As the universe expanded and cooled, this fog slowly began to fade, settling like mist, revealing a quiet morning landscape. When the haze finally lifted, the universe became transparent for the first time. And in that new clarity, the first true horizons began to form. Fact 5. The first stars wake. Eventually, little pockets of matter gathered together, drawn gently inward by gravity's patient pull. These early clusters grew denser, warming with each slow collapse until, at last, the first stars caught fire. They were enormous compared to the stars of today. Brilliant giants that lit the young cosmos with fierce but short-lived light. Their glow drifted outward, brightening regions that had never known illumination before. These ancient suns painted the darkness with soft, shimmering hues, signaling that the universe had entered a new age. Their starlight flowed outward like a quiet river, reaching toward places still untouched. Fact 6. Birth of galaxies. As more stars formed and gathered, the first galaxies took shape like island chains scattered across a dark and endless sea. Instead of spirals or neat structures, these early galaxies were irregular and wild, built from chaotic waves of star formation. Over time, gravity smoothed them into more graceful shapes, drawing the stars together into spirals, ellipses, and luminous clusters. Each galaxy became a glowing city of light, drifting through the vast, expanding space. Imagine them as lanterns slowly moving apart, each carrying billions of stories within its shining heart. And far beyond these first island galaxies, new cosmic patterns were already beginning to stir. Fact 7. The web of everything. As the universe continued to expand and cool, matter didn't spread out evenly. Instead, tiny ripples in density, faint whispers from the earliest moments, guided the flow of gas, dust, and dark matter into long, delicate strands. Over billions of years, these strands grew into what we now call the cosmic web, an immense, lace-like structure stretching across the universe. Galaxies gathered along these filaments like beads on invisible threads, separated by vast pockets of quiet emptiness. If you could drift above it, the universe would look like a glowing, three-dimensional tapestry. And along every thread of that tapestry, the next chapters of creation were slowly awakening. Fact 8. The universe learns to shine. Before stars and galaxies lit up the cosmos, the universe was a dim and shadowed place. But as the first generations of stars flickered into existence, their light began to travel farther than anything before them. Slowly, this starlight reionized the surrounding gas, turning the darkness into a transparent, softly glowing expanse. It was as if the universe, after a long and quiet slumber, gradually opened its eyes and began to glow. This newfound clarity allowed light to roam freely, painting the cosmos with warmth and gentle color. And that traveling light set the stage for every horizon we observe today. Fact 9. Gravity's slow, sculpting. Gravity works with an unhurried patience, shaping the cosmos not with forceful motions, but with a steady, irresistible pull. Over billions of years, it gathered stars into galaxies, galaxies into clusters, and clusters into vast superclusters. What seems still to us is actually a slow cosmic dance. Structures gently drifting, merging, and reshaping themselves in ways we can only witness through deep time. Every curve of a spiral galaxy, every arc of a cluster carries the signature of gravity's quiet craftsmanship. This gentle sculpting continues even now, guiding the universe into ever-changing forms. And farther out, where gravity weakens, the great stretch of expansion begins to take over. Fact 10. The faint background. Long after the universe's fog cleared, a delicate afterglow remained, a soft, uniform radiation filling every corner of space. This is the cosmic microwave background, the oldest light we can see, stretched and cooled over nearly 14 billion years. It hums at a temperature just above absolute zero, a quiet reminder of the universe's warm beginnings. Though faint and almost featureless, it carries tiny variations, like ripples frozen onto the surface of a calm pond. These ripples tell the story of where galaxies would form and how the cosmos would grow. And beyond this ancient glow, the expansion continues its slow and steady drift. Fact 11. The nature of distance. When we speak of the edge of the universe, it's not an edge we can walk to or touch. Space doesn't end. It simply extends, stretching in every direction without revealing a boundary. Distance itself becomes a shifting concept because the space between objects grows over time. Two galaxies may drift apart, not because they move, but because the universe expands between them, like dots on an inflating balloon. It feels strange, yet soothing, to imagine space quietly widening beneath our feet. And as it widens, the faintest galaxies slip softly toward the limits of our view. Fact 12. The Hubble drift. As light travels from distant galaxies, the expansion of space carries those galaxies farther away, causing their light to stretch into deeper shades of red. This gentle shift, known as redshift, is one of the clearest signs that the universe is expanding. The farther a galaxy is, the faster it appears to drift away, like lanterns floating on a slow-moving river. Even though nothing in space pushes them, the stretching fabric of the cosmos makes it seem as if they are quietly receding. This steady drift shapes the horizon of the observable universe, setting the outermost boundary of what we can see. And just beyond that boundary, countless galaxies continue their silent retreat. Fact 13. The redshift story. As light travels through the expanding universe, it stretches, not because it grows weaker, but because space itself gently lengthens its waves. This stretching shifts the color of the light toward the red end of the spectrum, creating a quiet record of cosmic distance. The deeper the redshift, the farther the light has traveled, and the older the message it carries. It's as though the universe whispers its history through color, allowing us to read time as softly as turning pages in a dim, peaceful room. Every hue tells a story of how far the cosmos has unfolded, and as the colors fade, they guide us toward distant regions drifting beyond our reach. Fact 14. The speed of expansion. Some galaxies grow so distant that they appear to retreat faster than light itself. This doesn't break any rules. Nothing is racing through space at impossible speeds. Instead, space is expanding between us, quietly creating distance faster than light can bridge it. These galaxies aren't running away. They're being carried by the swelling of the universe, like tiny seeds drifting apart on a calm but ceaseless breeze. In this way, vast regions slip beyond the possibility of communication, their light stretched until it can no longer arrive. Yet even as they fade from view, their silent presence shapes our understanding of the cosmic edge. Fact 15. Hubble's sphere. If you imagine a sphere centered on Earth, defined by all the galaxies receding from us at the speed of light, you have what cosmologists call the Hubble sphere. Inside it, light can still reach us, though slowly. But beyond this invisible shell, galaxies drift away faster than their own light can close the growing gap. It's not a wall or a limit, just a gentle threshold where expansion outweighs the ability of light to keep pace. The Hubble sphere isn't fixed. It grows as the universe evolves, letting new regions briefly fall into view before slipping away again. And beyond this shifting horizon, deeper mysteries wait with quiet patience. Fact 16. The quiet role of dark energy. Dark energy is one of the softest forces we know, not because it is weak, but because it works so gently and evenly that we hardly notice it. It doesn't push or pull in the way gravity does. Instead, it quietly encourages space to expand, adding a subtle acceleration to the universe's growth. Over billions of years, this gentle influence has become the dominant force shaping cosmic distance. Galaxies that once drifted apart slowly now separate more quickly, carried on the silent flow of dark energy. It acts like a calm, steady breeze blowing across the entire universe. And as it continues, it widens the gap between us and the farthest reaches of the cosmic horizon. Fact 17. The accelerating stretch. We often imagine the universe expanding at a constant pace, but in truth, its growth is speeding up. This acceleration means that every moment, distant galaxies slip farther away than they would by motion alone. Space stretches more rapidly than it did in the past, like a gentle tide rising ever so slightly faster with each passing hour. Though the change is slow on human timescales, across eons, it becomes a powerful sculptor of the universe's shape. As expansion accelerates, more of the cosmos drifts beyond the reach of our future sight, and with each quiet stretch, the edge of the observable universe grows softer and more elusive. Fact 18. The fate of faraway light. Light leaving distant galaxies begins its journey with hope, but as it travels, space continues to expand beneath it. The farther the light must go, the more it is stretched, its waves lengthening into cooler, gentler forms. Some light grows so faint and so red that it becomes nearly impossible to detect. Other photons are stretched so dramatically that they will never quite arrive at all, forever falling behind the speeding expansion. These lost messages drift quietly into the deep future, never reaching a waiting observer. And their fading echoes mark the boundary between what we can know and what will remain forever beyond our sight. Fact 19. Islands in the dark. As the universe expands and accelerates, only a small region around us will remain connected by gravity. Our local group, the Milky Way, Andromeda, and a handful of smaller companions, will stay bound together like a tiny cluster of lanterns in a vast night. Beyond this cluster, however, other galaxies will drift so far and so fast that their light will never again reach us. Over trillions of years, the cosmos will appear emptier, leaving each gravitational island alone in an ocean of quiet darkness. These islands will glow gently, solitary but serene, floating through an ever-widening sea. And beyond them, more distant worlds will slip softly beyond even imagination. Fact 20. The dimming cosmos. As galaxies retreat and their light stretches into longer wavelengths, the universe slowly dims. Photons become cooler, sparser, and harder to detect. Scenes that once blazed across the night sky will eventually soften into faint whispers of what they once were. It is not a sudden fading, but a gradual twilight, unfolding over unimaginable spans of time. Stars, nebulae, and clusters will still glow, but their light will need to travel farther through expanding space, making each glimmer more delicate. The cosmos will feel like a great room with lights gently lowered, leaving only the closest lanterns visible. And as that dimming continues, our view of the universe's edges will grow even softer. Fact 21. The observable bubble. The edge of what we can see is not a physical wall, but a bubble defined by how far light has been able to travel since the universe began. This sphere surrounds us in every direction, expanding as time passes because older and older light finally reaches our eyes. It's as though we live inside an ever-growing shell of visibility, watching deeper into the past with every passing moment. The farther out we look, the younger and more primordial the universe appears. This bubble is our cosmic horizon, a gentle boundary made not of matter, but of time itself. And beyond that horizon, countless regions drift silently where no light has yet arrived. Fact 22. The particle horizon. The particle horizon is the farthest distance from which any signal, any particle or whisper of light, could have reached us since the universe began. It marks the true outer limit of our cosmic knowledge, defined not by objects, but by the passage of time itself. Everything within this boundary has had just enough time to send us a message. Everything beyond it remains forever silent, not because it isn't there, but because its light simply hasn't arrived yet. It's like standing on a quiet shore at night, seeing only the waves close enough to reflect the moon. And somewhere beyond that darkness, more distant waves roll quietly on, unseen. Fact 23. The cosmic light horizon. The light horizon is different from the particle horizon, softer, quieter, and far more elusive. It marks the line beyond which light emitted right now will never reach us, no matter how long we wait. The expansion of space outpaces the journey of those distant photons, pulling their path longer than time will allow. Even if a galaxy shines brightly today, if it lies beyond this horizon, its glow will never cross the widening gulf. This creates a gentle separation between our region of the cosmos and others that drift away like lanterns carried by a growing tide. Beyond that drifting line, hidden worlds continue their quiet lives, forever out of reach. Fact 24. The event horizon of the universe. Just as black holes have event horizons, the universe itself carries a kind of horizon, a boundary that limits what we will ever be able to witness in the future. It isn't a wall in space, but a limit in time. Beyond a certain distance, events occurring today will never influence us, no matter how long the universe endures. Galaxies beyond this horizon will fade from view, growing dimmer until their final photons stretch beyond detectability. The cosmic event horizon is a reminder that even the universe has gentle boundaries shaped by time's steady flow. And beyond those boundaries, existence continues in quiet, unreachable regions of the infinite. Fact 25. The receding present. The farther we look into space, the further back in time we see. But there are galaxies so distant that even though they exist right now, we will never witness their present state. By the time their newest light reaches us, if it ever does, their stars, shapes, and histories will have changed beyond recognition. The universe's expansion stretches the moments between us, making the now of faraway galaxies slip quietly out of sync with our own. It's a gentle reminder that the cosmos moves at different rhythms in different places, and some rhythms drift so far ahead that they become forever beyond our sight. Fact 26. Beyond our reach. There are galaxies whose light will never touch us, not because they are faint, but because space expands faster than their photons can travel. These distant realms are not lost or gone. They simply inhabit parts of the universe separated from us by the quiet acceleration of space. Even as they shine brightly, their messages fall behind, stretched thin across the growing gulf. They remain forever beyond any conversation, like distant ships sailing over a horizon we can never cross. Yet their existence hints at a cosmos far larger than the one we can observe. And somewhere beyond that unreachable boundary, new worlds drift in silent mystery. Fact 27. The concept of no outside. It's natural to imagine the universe as a bubble floating in an empty void, but in truth, there may be no outside at all. Space doesn't sit inside anything. It is the arena where all distances and directions exist. Asking what lies beyond the universe may be like asking what's north of the North Pole. The question dissolves because the concepts no longer apply. The universe may be finite or infinite, curved or flat, but it has no edge in the way a surface or container does. This no outside idea makes the cosmos feel less like an object and more like a boundless, self-contained ocean. And within that ocean, every point drifts gently outward, carried by expansion with no shorter reach. Fact 28. The centerless ocean. In a universe that expands everywhere at once, there is no single center from which everything spreads. Every point in space watches every other point drift away, as though each were floating on a rising tide. No matter where you stand, it feels as though the expansion begins beneath your feet, stretching outward in all directions with quiet symmetry. This centerless nature is one of the universe's most calming mysteries. Nothing is privileged, and everywhere belongs equally to the cosmic flow. It's like standing in a vast fog where every direction looks the same, serene and unhurried. And as the fog expands, every observer becomes the center of their own gentle horizon. Fact 29. Curvature. Without borders, space can be curved without needing an edge, just as the surface of a sphere curves without a boundary. The universe might wrap subtly around itself, or it might stretch flatter than the calmest sea. But either way, it doesn't require an ending point. Curvature simply changes how lines behave. Parallel paths may slowly drift together or apart, creating a quiet geometry that shapes how we measure distance and time. This curvature is so gentle that we don't feel it, but it guides the structure of everything around us. Imagining such a shape is like picturing a dream that has form but no walls. And inside that dreamlike space, galaxies glide effortlessly along its hidden contours. Fact 30. The universe as a horizon machine. The expanding cosmos continuously creates new horizons, soft boundaries defined not by objects, but by the limits of light and time. As the universe grows, some horizons widen, letting new regions briefly come into view. Others retreat, pushing distant galaxies beyond the reach of future contact. The universe is always weaving, reshaping, and redrawing these delicate limits, like a painter softly adjusting the edges of a watercolor landscape. Each horizon tells a different story about how far we can see, how far we can travel, and how far information can flow. And beyond every horizon, more of the universe rests in quiet, unreachable beauty. Fact 31. The first light. Still traveling. Some of the oldest photons in existence began their journey more than 13 billion years ago, long before galaxies grew graceful arms or stars settled into steady rhythms. These particles of light have been crossing the universe for ages, weaving through expanding space like tiny messengers from a distant past. Their path has stretched so much that their energy has cooled into microwave wavelengths, soft, quiet, almost like a cosmic sigh. Yet they are still traveling, still drifting, still carrying the memory of a universe just beginning to bloom. And as they move, they illuminate the ancient boundary between what was and what is becoming. Fact 32. The last light we'll see. There will come a time when the most distant galaxies we can observe today will slip beyond the reach of future astronomers. Their final photons, the last light they will ever send our way, are already on their journey, racing against the accelerating expansion of space. Eventually, these faint glimmers will arrive, stretched thin and cool, like the final notes of a song fading into silence. After that, No new light from those galaxies will ever reach us again. Each dimming photon is a gentle farewell from a world we will never witness again. And beyond that quiet goodbye, the cosmos continues its slow retreat into darkness. Fact 33. Quiet messages from the early cosmos. The universe is filled with relics of ancient events, particles, waves, and signals that began their travels when everything was still young. These quiet messages float through space like drifting feathers, carrying information about moments long gone. Some reveal the temperatures of the early cosmos. Others show us how matter first gathered into patterns. Though faint and delicate, they help us reconstruct a universe we could never see directly. Listening to these whispers is like hearing the echo of a sunrise from ages past. And beyond the reach of these relics, newer stories wait, hidden in the stillness of unreachable space. Fact 34. Frozen echoes. Long after the universe became transparent, a gentle glow remained, the lingering warmth of a time when everything was still young and close. These frozen echoes, the cosmic microwave background, drift across the sky in all directions with perfect calm. They carry the faint imprint of tiny fluctuations, delicate patterns that reveal how matter gathered into the first seeds of galaxies. Though this glow has cooled to just a whisper above absolute silence, it still surrounds us like a soft blanket of ancient light. It is the universe's earliest memory, preserved in a glow so faint it feels like a dream. And beyond this quiet echo, the cosmos stretches into regions still untouched by any light. Fact 35. The oldest things we can detect. Among all the signals that reach us, some are unimaginably old, older than stars, older than galaxies, older even than the first heavy elements. These ancient imprints come not from objects, but from the early behavior of space-time itself. Tiny ripples in density, frozen into the cosmic background, reveal how the universe expanded during its earliest moments. Though they appear as gentle temperature differences, they hold the key to understanding the vast structure of today's cosmos. These oldest detectable traces act like fossils in a cosmic desert, marking where everything we see first began. And beyond those primordial fossils lie regions whose earliest signals will never reach us at all. Fact 36. Maps of the faintest light. Astronomers map the universe's oldest light with instruments as sensitive as they are patient. These detectors measure tiny changes in temperature and polarization that vary by mere millionths of a degree. From these subtle shifts, we create detailed maps of the cosmic microwave background. Intricate, softly modeled patterns that tell the story of the early universe's first stirring motions. Each bright and dim patch corresponds to regions that later blossomed into galaxies and clusters. These maps are like ancient star charts, guiding us not across space, but back through time itself. And as we explore them, we drift ever closer to the edge where light can no longer guide us. Fact 37. Light will never receive. In the far reaches of the universe, countless stars and galaxies shine with quiet brilliance, but much of their light will never touch us. As the expansion of space accelerates, the distance between us and those distant worlds grows faster than photons can cross. Their light stretches into longer and longer wavelengths, thinning into forms too faint for any detector to catch. These unreachable messages drift endlessly, like letters sent across an ocean whose shores drift farther apart each day. They remind us that the cosmos holds more beauty than we will ever witness, and beyond the glow, we can see lies a vast darkness filled with silent, unseen light. Fact 38. The universe, growing opaque again. As expansion continues, the universe slowly becomes opaque once more, not with fog or matter, but with distance. When light is stretched far beyond the visible spectrum, it slips into wavelengths so long that space itself muffles them into near silence. Over unimaginable spans of time, distant galaxies will fade from view, not because they stop shining, but because their light can no longer reach us in any recognizable form. The night sky will gently lose its depth, like a watercolor washed into softer tones. This quiet dimming is not a loss, but a natural part of the universe's long, slow unfolding. And beyond the fading glow, the cosmic edges retreat into peaceful, unreachable calm. Fact 39. The last galaxies we can witness. At the edge of our observable universe lie the most distant galaxies ever detected. Tiny smudges of ancient light shaped when the cosmos was still a child. These galaxies appear faint and stretched because their light has traveled for billions of years, pulled across the widening fabric of space. Their structures are simple, fragile, and glowing with the first generations of stars. Over time, even these final visible galaxies will slip beyond reach as expansion accelerates. For now, though, they shimmer softly at the edge of sight, like candles glowing in a distant fog. And beyond them lies a frontier where no light will ever return, only the quiet of infinite distance. Fact 40. The vanishing frontier. The edge of the observable universe isn't fixed. It drifts and shifts as time passes. Light from distant objects continues to arrive, expanding the bubble of what we can see. But even as new sight lines open, others are slowly closing. The accelerating expansion causes the observable frontier to slip farther away from us, like a shoreline retreating with each gentle wave. Over billions of years, more galaxies will fade beyond detection, leaving only their ancient light as a final whisper. This frontier is not a barrier, but a fading horizon, always moving, always softening. And beyond it, the universe stretches into realms we will never touch. Fact 41. The most distant galaxy found. So far, astronomers occasionally glimpse galaxies so far away that their light began traveling when the universe was only a few 100 million years old. These galaxies appear as faint smudges, their colors stretched deep into the infrared by the expansion of space. Their stars are young, their shapes irregular, and their light fragile, but they represent some of the earliest cosmic structures ever seen. Each discovery pushes the boundary of the known universe just a little farther. Finding them is like catching the faint glimmer of a lantern across an ancient sea. And with every new detection, we step a little closer to the dawn where galaxies first awakened. Fact 42. Galaxies almost lost to time. Between the brightest distant galaxies and the invisible depths beyond lies a quiet region where light barely survives the journey. These galaxies sit at the very edge of detection, their photons stretched almost beyond recognition. We see them as ghostly silhouettes, their shapes blurred by distance and cosmic expansion. Many of their details, their stars, their dust, their histories, are softened into gentle uncertainty, like memories fading in a dream. Yet even these nearly forgotten galaxies help map the universe's earliest chapters. And beyond them lies a realm so distant that even the strongest light dissolves into silence. Fact 43. Light from when the universe was young. The most distant light we observe today began its journey when the universe was still in its youth, barely beginning to take shape. These ancient photons have traveled across expanding space for more than 13 billion years, carrying with them the story of a cosmos filled with newborn stars and forming galaxies. Their journey has stretched their wavelengths into soft, gentle reds, turning once bright glows into faint murmurs barely detectable by sensitive instruments. Each photon is like a tiny message from the universe's childhood, preserved across cosmic time. And as we listen to them, we catch glimpses of a world that has long since transformed. Fact 44. The Dawn Epoch. There was a time known as the Dawn Epoch, when the very first stars flooded the universe with new light. These stars formed in small, fragile galaxies that flickered like sparks in a vast, dark sea. Their illumination slowly cleared away the remaining cosmic haze, allowing light to travel farther and farther across the widening universe. Though we can only see hints of this epoch, its glow marks one of the most transformative periods in cosmic history. It was the moment the universe truly learned to shine, scattering darkness with its first great radiance. And beyond that shining dawn, galaxies continued to bloom like distant cosmic flowers. Fact 45. Fragile light from fragile worlds. The early universe was home to galaxies so delicate and faint that their light seems almost too soft to survive the long journey to us. These tiny systems held only a few clusters of stars, glowing just enough to pierce the surrounding dark. Their light traveled through billions of years of expansion, stretched nearly beyond recognition, yet still managing to arrive at our instruments. They represent the most fragile beginnings of galactic formation, small, simple, but profoundly important. Their gentle glow feels like the flicker of a candle carried across an impossibly large room. And beyond those fragile worlds, even fainter structures drift quietly at the edge of visibility. Fact 46. The redshift record holders. Among the faintest smudges in the sky are galaxies that hold the record for the highest redshifts ever observed. Their light has been stretched to such extreme lengths that it arrives as a soft whisper in the infrared, barely distinguishable from the background glow of the universe. These record-holding galaxies lived when cosmic time had just begun to unfold, when stars were few, matter was unsettled, and everything was still learning how to form structure. Each discovery pushes back the frontier of cosmic history by just a little more, like uncovering an older page in a very ancient book. And beyond even these record holders, countless galaxies drift unseen in the dimness. Fact 47. How early stars shape the edge. The earliest stars were immense, bright, and short-lived, cosmic giants born from pristine hydrogen and helium. Their intense radiation carved out bubbles of clear space, melting away the lingering fog of the young universe. As they lived and died, they seeded their surroundings with heavier elements, paving the way for new generations of stars. These first suns shaped the distant edge of the observable universe, illuminating regions we can still faintly detect today. Their glow softened the darkness and pushed back the cosmic night, leaving footprints of light that stretch across billions of years. And far beyond their reach, deeper shadows continued to drift untouched. Fact 48. The first clusters emerged. As gravity gently gathered matter together, small galaxies began to merge into the earliest clusters, loose gatherings of stars and gas bound by their mutual pull. These clusters weren't as massive or organized as the grand structures we see nearby today. Instead, they resembled scattered communities of light, slowly coming together in the vast expanse. Over time, They grew into the great clusters we know now, holding thousands of galaxies within their warm gravitational embrace. These early clusters were like sparks forming constellations in the deep cosmic dusk. And just beyond them, new filaments of matter stretched outward, guiding the growth of even larger structures. Fact 49. Hidden galaxies behind cosmic dust. Not all galaxies near the edge of the observable universe reveal themselves easily. Some are shrouded behind clouds of cosmic dust that dim and scatter their ancient light. This dust, made from tiny grains forged in the hearts of long-gone stars, absorbs the brighter wavelengths and lets only the faintest infrared glow pass through. Detecting these hidden galaxies requires careful sensing, like listening for a heartbeat beneath layers of blankets. Yet they are there, quiet, persistent, and full of stories. These obscured galaxies remind us that the universe keeps secrets tucked behind its softest shadows. And beyond them, even more hidden realms drift unseen in the cosmic night. Fact 50. The silent march of time on distant systems. Distant galaxies evolve across such vast stretches of time that we can only see them at a single moment in their long histories. We view them as they once were, young, clumpy, full of new stars, even though, in their own regions of space, they may now be grand spirals or dim remnants. Time moves differently when distance is great. The farther a galaxy lies, the younger it appears, as if trapped in a cosmic photograph. This quiet time delay softens our understanding of the universe, reminding us that age and distance weave together like threads in a tapestry. And as we look deeper, we step further into a past no longer visible to its own galaxies. Fact 51. The curvature of the universe. The universe may seem flat and endless to our eyes, but its true geometry is subtle and gentle. Space can be curved, bending slightly like the surface of a smooth hill, or arching like a vast, invisible dome. This curvature is so mild on cosmic scales that we barely detect it, yet it shapes the paths light takes as it moves across the heavens. Whether the universe curves inward, outward, or not at all affects how far we can see and how distant horizons form. It's like trying to sense the shape of a room by listening to the echoes in the dark. And whatever its curves may be, they lead us quietly toward the next layers of cosmic mystery. Fact 52. Flatness like an endless sheet. Measurements of the cosmos suggest that the universe is remarkably flat, not in the sense of being two-dimensional, but in how its geometry behaves. Parallel lines stay parallel, and light travels in straight paths across unimaginable distances. This flatness gives the universe an expansive, open feeling, like standing in a vast field where the horizon stretches without curve or corner. It's a quiet kind of infinity, where distance unfolds smoothly and evenly in every direction. The universe's flatness makes space feel boundless, serene, and softly balanced. And as we drift through it, the idea of edges becomes even more dreamlike and distant. Fact 53. Possible closed shapes. Yet cosmology leaves room for gentler possibilities. The universe might be subtly curved, looping around itself in ways too grand to detect. In such a model, traveling far enough in one direction could eventually bring you back to where you started, not by turning, but by following a straight path through curved space. This doesn't create walls or borders. It creates a self-contained cosmos, much like the surface of a sphere, but expanded into 3 dimensions. Imagining such a shape is like picturing a soft, cosmic shell with no outside and no edge, only endless continuation. And whether or not this loop exists, It invites us to dream of a universe that folds gently into itself. Fact 54. Open geometries that drift forever. Another possibility is an open universe, one that curves outward ever so slightly. In this shape, space expands without looping back, giving every direction a sense of gentle divergence. Lines that begin parallel slowly drift apart, like feathers carried on separate breezes. An open universe feels airy, vast, and quietly unbounded. A place where travel could continue endlessly without the slightest hint of return. This open geometry captures the feeling of infinite drifting, where horizons stretch farther and farther with each passing moment. And beyond that outward curve lies the deep, delicate mystery of what infinity truly means. Fact 55. Inflation's imprint on shape. In the universe's first tiny fraction of a second, space expanded at an astonishing pace, a moment known as cosmic inflation. Though this burst of growth was brief, it left a lasting signature on the shape of everything that followed. Inflation smoothed out the universe, ironing away large-scale curvature and spreading matter evenly across vast distances. The result is the calm, almost perfectly flat cosmos we observe today. It's as though the universe began with a deep, quiet breath that gently stretched its fabric smooth. And even now, that ancient breath shapes how far we can see and how horizons softly form. Fact 56. How curvature affects horizons. The universe's curvature, subtle as it is, influences the way horizons appear and expand. In a curved space, distances don't behave quite the way our intuition expects. Light may travel along paths that bend, and the size of the observable universe can shift depending on how space is shaped. If the cosmos is slightly closed, horizons might feel closer. If it's open, they may stretch even farther. These differences are delicate, but they whisper clues about the fundamental structure of everything. Curvature adds a quiet artistry to the universe, guiding light with invisible strokes. And beyond those strokes, the cosmic edge unfolds in shapes we can only imagine. Fact 57. Geometry as a quiet sculptor. The geometry of the universe acts as a silent sculptor, shaping not only the paths of photons, but also the growth of galaxies and clusters. A flat universe lets structures spread in balanced harmony, while curved geometries gently influence how matter gathers and drifts. Though we rarely notice it, geometry defines the very stage on which cosmic evolution takes place, setting the rules for how horizons form and how distance stretches across space. It is a soft, mathematical music playing beneath everything, steady, subtle, and timeless. And guided by that quiet music, the universe continues its slow expansion toward deeper, softer horizons. Fact 58. The smoothness of everything. On the largest scales, the universe is astonishingly smooth. No matter which direction you look, the cosmic landscape appears almost the same, as though painted with a single, steady brushstroke. Galaxies cluster in delicate webs, yet when viewed from afar, their patterns blend into a quiet uniformity. This smoothness is a legacy of the early cosmos, when inflation spread matter evenly across vast distances, leaving only tiny ripples that would later grow into galaxies. It's as if the universe began with a gentle calm that still echoes across space today. And within that calm, the edges of our sight rest like soft, distant horizons. Fact 59. Tiny fluctuations at the edge. Though the universe appears smooth from afar, it also carries tiny fluctuations, tiny variations in density frozen into the cosmic microwave background. These fluctuations are like the faintest speckles on an ancient canvas, patterns that reveal where matter was just slightly denser or slightly thinner. Over billions of years, those tiny differences shaped everything: galaxies, clusters, superclusters, and the great cosmic web. Without them, the universe might have remained a featureless expanse. They are subtle fingerprints from the dawn of time, preserved in the faintest glow of ancient light. And as we follow them outward, they guide us to the edge where the universe becomes nearly uniform again. Fact 60. Why edges don't need borders. In everyday life, edges mark boundaries. The end of a table, the shore of a lake, the walls of a room. But the universe doesn't follow that familiar pattern. Its edge is defined not by walls, but by limits of light, time, and motion. We cannot see beyond certain distances because light hasn't had enough time to reach us, not because something blocks the way. The universe may go on endlessly, smoothly, quietly, without ever presenting a true border. Its edge is more like a horizon at sea, always present, always shifting, never a solid line. And beyond that horizon, the cosmos stretches into silence we can only dream about. Fact 61. Space that could be larger than we know, everything we see, every star, every galaxy, every soft whisper of ancient light, fits within our observable sphere. But beyond that glowing shell may lie regions of space far larger than anything we can ever witness. The universe could stretch on for trillions of light years, repeating patterns or forming entirely new ones, all hidden beyond the reach of time and distance. These unseen expanses are not separate worlds, but seamless continuations of the same cosmic fabric we inhabit. It's comforting to imagine the universe extending in quiet, endless calm. And far beyond our horizon, that calm may stretch into distances without limit. Fact 62. The possibility of other regions. Cosmology allows for the idea that space may not be perfectly uniform in every direction. There might be vast regions where the density of matter differs, where galaxies cluster differently, or where cosmic conditions follow their own gentle patterns. These regions would be so far away that no signal could ever cross the gulf separating us. Yet they would still belong to the same universe, chapters of the same cosmic story, written in pages we can never read. Thinking of these remote realms is like imagining landscapes beyond a distant mountain range. We cannot see them, but we know the world continues quietly on the other side. Fact 63. Eternal inflation as a soft dream. One idea, known as eternal inflation, imagines the universe as part of a much larger cosmic sea. In this view, inflation never ended everywhere. Instead, it continued in far-off regions, creating vast bubbles of space, each becoming its own universe with its own laws and shapes. If this is true, we exist inside just one calm pocket of a much grander reality. But these other pockets would be unreachable forever, separated by space-time expanding faster than any signal could cross. It's a gentle, poetic vision. Countless universes drifting like lanterns across an infinite night. And though we may never see them, the idea adds a quiet wonder to our own small corner of existence. Fact 64. Bubbles in the cosmic sea. If the idea of eternal inflation holds true, then our universe may be just one bubble floating in a vast, ever-growing cosmic sea. Each bubble would contain its own space-time, forming and expanding in isolation, never touching or revealing what lies beyond its curved boundaries. These cosmic bubbles might differ in size, shape, or the laws of physics that guide their evolution. Even though we cannot observe them, imagining their quiet presence adds depth and softness to our sense of the unknown. It is soothing to picture countless universes drifting like gently rising bubbles, each glowing with its own quiet life. And somewhere among them, ours expands silently, carrying its own stories into the infinite. Fact 65. Boundaries. Between realms. If multiple cosmic bubbles do exist, the boundaries between them would not be sharp walls or solid edges. Instead, they would be smooth transitions where expanding regions of space-time simply never meet. These boundaries would be unreachable fronts, moving away faster than light can travel. Even if other universes exist within this grand cosmic foam, the space between us expands too quickly for any signal, particle, or traveler to cross. These drifting boundaries feel more like gentle separations in a dream than walls in a physical world. And beyond every unseen border, another soft realm might glow, forever out of reach. Fact 66. Why we may never know. The greatest mysteries of the cosmos often lie beyond the limits of observation. Because light can travel only so fast, and space expands without hurry, vast regions of existence remain permanently hidden. Whether the universe is infinite, whether other realms drift nearby, whether cosmic bubbles fill a larger sea, these questions rest just beyond our reach. We may never know the full scope of reality, not because it is forbidden, but because the laws of nature draw gentle curtains around our view. There is a certain peace in accepting these limits, like watching a horizon fade into twilight. And within that twilight, the universe keeps its quiet secrets, serene and unbroken. Fact 67. Theoretical edges without walls. Some ideas in cosmology imagine edges that aren't edges at all, transitions where the properties of space simply change. These aren't abrupt borders, but smooth gradients where laws of physics might shift, lighten, or soften. If such theoretical boundaries exist, they would lie far beyond any horizon we could ever reach, hidden behind the limits of light itself. They wouldn't feel like cliffs or endings, but more like the gentle blending of one color into another in a vast cosmic watercolor. These quiet transitions remind us that the universe, even at its boldest, moves with softness and subtlety. And somewhere beyond our sight, its nature may shift in ways we can only dream about. Fact 68. Quiet cosmological speculation. Cosmologists often explore ideas that cannot yet be tested, not boldly or with certainty, but with a kind of scientific daydreaming. These speculations, from multiverses to higher dimensions, serve as gentle thought experiments that expand our sense of what might be possible. They do not claim truth. They simply offer new ways to imagine the vastness beyond what we can observe. In their own quiet way, they keep our curiosity awake while letting our expectations rest softly on uncertainty. Thinking about these possibilities is like gazing at a horizon and wondering what coast lies beyond the mist. And even without answers, the wondering itself becomes a peaceful part of the journey. Fact 69. Patterns of infinite space. If the universe is infinite, or even just unimaginably large, certain patterns may repeat across distances too vast for light ever to traverse. Galaxies arranged in familiar shapes, clusters forming similar webs, or large-scale structures echoing one another like recurring motifs in a quiet symphony. These repetitions would not be mirrored images, but natural outcomes of gravity, matter, and time at work on grand scales. Though we will never witness these distant echoes, their possibility adds a soothing order to the cosmos. It is comforting to imagine that far beyond our view, space continues in gentle, repeating rhythms. And somewhere in that endlessness, the universe hums with patterns we will never fully see. Fact 70. The comfort of the unknown. There is a quiet comfort in knowing that not everything about the universe can be understood. The vast stretches beyond our cosmic horizon hold mysteries that will forever remain just out of reach, wrapped in silence. Instead of feeling unsettling, this can bring a sense of peace, as if the universe is offering us space to wonder without needing all the answers. The unknown becomes a soft, expansive place where imagination can drift freely, unconfined by certainty. In this way, the cosmic edge feels less like a boundary and more like a gentle invitation to dream. And as we rest, that mystery settles around us like a warm, star-lined blanket. Fact 71. The far future of cosmic distance. As the universe continues to expand, the distances between galaxies will grow wider and calmer over unfathomable ages. Light will take longer to cross these ever-stretching spaces, and the familiar shapes of the cosmos will subtly rearrange themselves over trillions of years. Clusters will drift apart like islands drifting across a cosmic tide, each carrying its own quiet history. The universe of the distant future will be slower, softer, and quieter than the one we know today. It will be a place where distances hum with serenity and where horizons stretch like gentle fading lines. And beyond those lines, the darkness will widen into peaceful, endless space. Fact 72. Galaxies leaving our reach. Already, many galaxies are moving away from us faster than their light can ever catch up. As cosmic acceleration continues, even galaxies we can see today will eventually drift beyond the reach of future observers. They will not blink out suddenly. Instead, their light will fade slowly, stretch thinner and cooler, until it becomes indistinguishable from the background glow. Over time, only the galaxies within our own gravitational neighborhood will remain visible. These retreating galaxies slip away like distant lanterns carried by a tide we cannot resist. And each one that fades marks the quiet expansion of the universe's ever-softening edge. Fact 73. The silent isolation of the local group. As more distant galaxies drift forever beyond our reach, only our small gathering of galaxies, the local group, will remain gravitationally connected. The Milky Way, Andromeda, and their smaller companions will stay bound together, drifting through the vast, expanding darkness like a tiny fleet of quiet ships. Over trillions of years, the universe outside this cluster will slip away into invisibility, leaving our local cosmic island alone in an ocean of deep, unbroken night. This isolation won't be abrupt. It will unfold slowly, softly, like a long twilight settling across the stars. And in that twilight, our little group of galaxies will become the sole lanterns in an ever-widening sea. Fact 74. Stars fading into darkness. Even stars, the warm hearts of galaxies, cannot shine forever. Over unimaginable spans of time, they will burn through their fuel and dim into cooler, quieter forms. The brightest stars fade first, leaving behind long-lived red dwarfs that glow softly for trillions of years. Eventually, even those gentle embers will cool, becoming faint, dark cinders, drifting silently through space. The universe will grow dimmer with each passing epoch, its once vibrant constellations dissolving into a velvety black. This slow fading is not tragic. It is calm, inevitable, like a candle slowly lowering its flame. And beyond the last flickers of starlight, the cosmos will slip into a serene and gentle night. Fact 75. Black hole era drifting. In long after the last stars have dimmed, black holes will remain as the final luminous actors in a darkening universe. These massive objects will quietly dominate the cosmic landscape, swallowing stray matter and glowing faintly with the energy of infalling particles. Over time, even they will begin to evaporate through a slow quantum process, releasing tiny whispers of radiation into the emptiness. This era will stretch across unimaginable durations as black holes gradually shrink and fade. Their quiet presence marks one of the final chapters in the universe's long, unfolding story, and beyond their eventual evaporation lies a deep calm, where only the faintest traces of energy drift through the dark. Fact 76. The slow evaporation of everything. In the far future, when stars have faded and galaxies have grown faint, even the darkest corners of the universe will continue to change. Black holes, once the most enduring objects in the cosmos, will slowly lose their mass through an almost imperceptible process. Bit by bit, particle by particle, they release tiny streams of radiation into the vast emptiness. This evaporation is so slow that it can take far longer than the age of the current universe, unfolding over timescales that stretch beyond imagination. It is a quiet unwinding, a soft release of energy into the growing dark. And as each black hole fades, the universe becomes a little more silent, a little more serene. Fact 77. Hawking's Whisper. The radiation that causes black holes to evaporate is known as Hawking radiation, a faint, ghost-like glow predicted by quantum physics. It's not a bright light, but a delicate, subtle whisper at the edge of existence. This radiation emerges because space around a black hole is alive with quantum fluctuations, where pairs of particles flicker in and out of being. Occasionally, one particle escapes, carrying away a tiny amount of the black hole's energy. Over unimaginable spans of time, these whispers slowly unweave even the largest black holes. Hawking radiation is like the universe's softest breath, gently smoothing away the last massive structures. And beyond these fading whispers lies a cosmos settling into perfect quiet. Fact 78. The universe, thinning to almost nothing. After the stars, after the galaxies, after the black holes have slowly evaporated, the universe will enter an era where matter becomes scarce and diffuse. Particles grow farther apart as space continues to expand, until the cosmos resembles a vast ocean of nearly empty darkness. Energy spreads thinly across this growing expanse, its warmth softening into cooler and quieter forms. Even the rare particles that drift through this darkness rarely meet, passing one another like solitary travelers in an endless night. It is a vision not of despair, but of tranquility, a cosmic silence that unfolds gently, without hurry. And beyond this thinning calm lies the final, peaceful fade of the universe's long story. Fact 79. Heat death as a gentle fade. In the farthest reaches of cosmic time, the universe may drift toward a state known as heat death. Not an ending with fire or collapse, but a quiet settling. In this future, temperatures even out across space until there are no gradients left to drive motion, structure, or change. Everything becomes smooth and still, like a vast lake with no ripples. Matter thins, energy spreads, and the cosmos enters a soft, steady calm where nothing stirs. This gentle fade is less an ending and more a long exhale, a final quiet resting of all things. And beyond that serene equilibrium, only the memory of a once luminous universe remains. Fact 80. The endless calm of the far future. As heat death deepens, the universe becomes a place of profound stillness. There are no stars to shine, no galaxies to drift, no black holes to anchor the darkness. Only the faintest particles and whispers of radiation traverse the immense, growing emptiness. time stretches softly onward, its passage marked not by events, but by the gentle persistence of existence itself. In this silence, the cosmos feels peaceful, weightless, and utterly unhurried. It is a future filled not with endings, but with a vast, tranquil quiet, the calmest chapter of all. And within that calm, the idea of an edge becomes softer than ever, fading into infinity. Fact 81. What infinity means in cosmology. Infinity, in the cosmic sense, is not a number to reach, but a concept to imagine, a space that continues without boundary, without limit, without a final stopping point. It may describe the size of the universe, the stretch of time, or the number of possible worlds that could exist. Infinity is soft in this context, not overwhelming, but gently expansive, inviting thoughts to drift without constraint. It represents a universe that doesn't need edges to feel complete. To think of infinity is to let the mind float beyond horizons, embracing a calmness as deep as the night sky. And from this infinite perspective, every point in the universe becomes a quiet doorway to wonder. Fact 82. Boundless but finite. Some models of the universe suggest a shape that is finite in size but has no edges, a cosmic structure that loops back on itself in dimensions we cannot easily imagine. In such a universe, you could travel forever without encountering a wall, yet the total volume would still be limited. It would feel boundless to any traveler, like walking across the surface of a sphere without ever finding an end. This idea is soothing in its simplicity, a cosmos that is whole, complete, and quietly self-contained. A universe that is finite, yet without borders, invites us to see space as a gentle continuum. And within that continuum, every direction stretches into a calm, unbroken path. Fact 83. Shapes that loop forever. If space truly curves in just the right way, it might fold back on itself in a kind of cosmic loop. Light could eventually return from the opposite direction, carrying whispers of a journey around the universe. Though such looping signals would be faint and extraordinarily difficult to detect, the possibility adds a poetic twist to cosmic geometry. It imagines a universe where paths are endless, where movement has no final boundary, and where light itself could one day circle the whole of existence. This looping cosmos feels like a gentle labyrinth, expansive, continuous, and filled with pathways that wander forever. And somewhere along its endless curves, horizons soften into pure possibility. Fact 84. Sizes too big to comprehend. Even if the universe is finite, its size may be so immense that no human mind can fully picture it. The observable portion we can see might be only the smallest fragment of a vastly larger whole, like a single candle flickering in an enormous, unlit hall. Distances stretch into trillions of light years, and beyond that, even more space may extend quietly without ever touching a border. The sheer scale inspires a feeling of peaceful awe, not fear, but wonder softened by distance. In this grand immensity, we are tiny but not insignificant, part of a vast calm stretching into every direction. And beyond even that calm lie expanses that drift beyond all imagining. Fact 85. Thinking about infinity before sleep. Infinity has a way of loosening the mind, especially when considered at the end of a long day. When you think about unending distance, a space that stretches softly without limit, the mind gently drifts away from its usual boundaries. Worries feel smaller, edges feel less sharp, and thoughts float more freely. Infinity isn't something to solve. It's a feeling, a quiet openness that allows the imagination to wander without pressure or fear. As you picture infinite space, let your thoughts expand like a slow breath dissolving into the night. And in that gentle expansion, find a sense of restfulness that holds you like a soft cradle. Fact 86. Endless distance is comfort. There is something soothing about the idea of distances so vast they become almost abstract. Trillions of light years, horizons that slip ever outward, galaxies drifting into unreachable calm. All of it reminds us that the universe is patient and unhurried. In such immensity, our own concerns shrink into perspective, softened by time and distance. The endlessness becomes comforting, like a wide ocean that quietly absorbs every ripple. Thinking of these deep distances can bring a sense of floating, as though the mind itself is suspended in starlight. And in that floating, the universe feels like a peaceful place to rest. Fact 87. How horizons suggest the infinite. When we talk about cosmic horizons, limits formed by time, light, and expansion, they often give the illusion that something lies beyond them without end. Horizons always hint at more because they never feel like barriers. They simply mark the edge of what we can presently know. The universe may not be infinite, but horizons create the sensation of infinity by constantly retreating as we approach. They guide us to imagine the vastness that stretches out past our sight. Each horizon is like a line drawn in soft sand, shifting gently with the cosmic tide. And beyond it, our thoughts are free to explore the wide, limitless dark. Fact 88. The quiet paradox of expansion. The universe expands, everywhere at once, yet no object feels the wind of motion. Galaxies drift apart without any force pushing them, carried by the swelling fabric of space itself. This creates a gentle paradox. Everything moves apart, but nowhere is there a center of expansion. Every observer sees themselves as the still point from which motion unfolds. It is a calm, elegant contradiction, a universe stretching gently in all directions, with no preferred place to begin. This paradox feels less like a puzzle and more like a quiet reminder that cosmic truths don't always match our everyday intuition. And in that mismatch, the universe becomes a softer, more mysterious place to dream. Fact 89. The mathematics of boundlessness. Mathematics helps us describe realities too large for the imagination, offering symbols and equations that sketch the shape of the infinite. Through these tools, cosmologists explore spaces with no edges, times with no beginnings, and distances that drift endlessly outward. These ideas are not cold or rigid. They are gentle structures that hold the universe's vastness in delicate balance. Math becomes a kind of language for serenity, precise, calm, and quietly profound. In its careful lines and curves, we find a way to imagine what cannot be seen. And through that imagination, boundlessness feels a little more familiar, a little more peaceful. Fact 90. Infinity as a sleepy companion. Infinity can seem intimidating when viewed sharply, but when approached softly, it becomes a soothing presence. It is the idea that there is always more space, more time, more possibility beyond what we can touch or measure. Infinity asks nothing of us. It simply invites us to rest in the knowledge that the universe is larger than our worries, grander than our limits, and calmer than our busy thoughts. In this sense, infinity becomes a companion, a quiet reminder that we are floating in a gentle, unending sea. As you picture that endlessness, let the mind relax into its soft, expansive embrace. And within that boundless calm, the edges of the universe drift into a peaceful haze. Fact 91. Stories. We tell about cosmic boundaries. For as long as people have looked at the night sky, They've wondered where the universe ends. Before science offered its gentle explanations, stories filled the gaps. Celestial domes, golden walls, spiraling heavens, and realms guarded by gods or spirits. Though these tales were not literal, they revealed a timeless truth. Humans seek meaning at the edges of things. Even now, as we talk about horizons and expanding space, we are still telling stories, only with starlight and mathematics instead of myths. These stories help us make peace with the vastness, giving shape to the unshaped. And beyond every tale lies a cosmos far quieter and deeper than words can reach. Fact nice number 92. Ancient views of the universe's edge. Across cultures, civilizations imagine many kinds of cosmic edges. Great oceans beyond the sky, mountains holding up the heavens, or endless fields where stars were hung like lanterns. These visions were gentle attempts to understand the unknown using the language of the familiar. Even though we now know the universe has no outer wall or boundary, these ancient ideas remind us of the comfort people find in picturing the world as a safe, enclosed space. Their myths shine like soft lanterns from long ago, illuminating our shared desire to understand the night. And as we drift forward, we carry those echoes with us like warm, ancestral memories. Fact 93. The evolving border of knowledge. What we call the edge of the universe has moved many times throughout history, not because the cosmos changed, but because our understanding did. Telescopes expanded our reach, revealing galaxies where we once imagined empty darkness. New instruments continue to stretch the border of what we can know, as if the universe patiently peels back layers for us to discover. Yet no matter how far we look, another horizon always waits, just beyond the limit of our tools. This ever-shifting edge is a gentle reminder that knowledge is not a destination, but a slow, luminous journey. And with every new discovery, the boundary of the unknown becomes just a little more beautiful. Fact Ningdai 4. Light as a messenger from the unknown. Every beam of light that reaches us from the distant universe is a quiet messenger, carrying news from places we will never touch. These photons travel for billions of years, slipping through expanding space with unwavering patience. Along the way, they weave through clusters, drift past dust clouds, and stretch into longer wavelengths as the universe gently grows. By the time they arrive, they are softened by the journey, like delicate letters worn smooth by time. Each faint glimmer reminds us that even the farthest regions of the cosmos can whisper their stories, and beyond those whispers lies a silent expanse waiting for light that may never arrive. Fact 95. How curiosity expands our own horizons. Every time we wonder about the edge of the universe, our own inner horizons widen. Curiosity stretches the mind in the same way expansion stretches space, gently, steadily, without ever needing to stop. It invites us to imagine distances beyond comprehension, times beyond memory, and possibilities beyond certainty. In reaching out with questions, we create new pathways in our understanding, opening soft doorways to deeper wonder. Curiosity becomes a kind of inner starlight, glowing quietly within us. And just like the cosmos, our thoughts expand into new, peaceful realms with every question we breathe. Fact 96. The human mind, reaching outward. Though we are tiny compared to the universe, our minds have a remarkable ability to reach far beyond our physical place in it. With imagination and science, we travel billions of light years in thought, drifting effortlessly to places our bodies will never go. This inner journey turns the night sky into both a map and a mirror, showing us the vastness outside while reflecting the vastness within. In this way, contemplating the cosmic edge becomes a gentle meditation, blending knowledge with quiet wonder. As the mind wanders outward, it softens, finding room to rest in the immensity. And beyond each mental horizon lies another, inviting deeper calm. Fact 97. Dreaming of places we'll never see. There is a quiet beauty in dreaming of worlds that lie beyond our reach. The far edges of the universe hold galaxies, stars, and wonders that no telescope will ever capture. Yet our imagination drifts to them effortlessly. These unreachable realms become peaceful landscapes in the mind, soft clusters glowing at the brink of infinity, swirling nebulae forming in tranquil darkness, horizons that dissolve into starlit haze. Dreaming of such places frees us from the limits of sight and space. In these inner journeys, the cosmos becomes a comforting companion, and beyond every imagined horizon lies another, waiting softly for our thoughts to wander. Fact 98. Why wonder makes us feel small and safe. Feeling small in the face of the universe is not frightening. It is soothing, like standing under a vast sky and realizing you don't need to carry everything alone. The cosmos stretches so far beyond our concerns that our worries naturally fade into perspective. This sense of smallness invites stillness, grounding us in the present moment while reminding us that we are part of something immeasurably larger and calmer than ourselves. In that feeling, safety blooms, a quiet trust that the universe holds us gently within its vast embrace, and from that comfort, wonder flows like a soft tide. Fact 99. The universe as a gentle mystery. The universe is full of unanswered questions, from the shape of space to the fate of distant galaxies. Yet these mysteries don't press on us. They simply exist, waiting with quiet patience. The more we learn, the more we realize how much remains hidden, like layers of a soft, cosmic fog. Embracing the unknown lets us rest in curiosity rather than certainty. It transforms the night sky into a gentle mystery, a puzzle meant to soothe rather than challenge. This mystery is not a barrier, but an open door, inviting us to wander through the dark with peaceful wonder. And in that wandering, we become part of the story the universe continues to write. Fact 100. The edge as a place within ourselves. When we speak of the edge of the universe, we often imagine some distant frontier where light grows thin and space stretches into silence. But in another sense, that edge is also something we carry inside us, the boundary between what we know and what we dream. Each time we let our thoughts drift outward, beyond the reach of telescopes and theories, we create an inner horizon shaped by curiosity and wonder. The more we explore, the farther that inner horizon moves, always opening into new, quiet spaces. In this way, the edge of the universe is not just a distant limit, but a gentle expansion of the mind itself. And every time we look up at the stars, that inner edge softens and stretches, inviting us to wander a little farther. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. We've drifted from the universe's quiet beginnings to the soft horizons where light fades into silence, exploring the edges of infinity one sleepy fact at a time. If you enjoyed drifting through these peaceful cosmic mysteries, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your ideas help guide our next quiet voyage through the night. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your soft journey through the universe. Sweet dreams, and see you among the stars.